Welcome to our channel. Today, we're diving into the fascinating world of astronomy, a field of study that compels us to look up in wonder and question the very nature of our existence in this vast universe. We find ourselves drawn to celestial objects like planets, those wanderers of the cosmos, each holding mysteries waiting to be unraveled. Have you ever wondered why planets are spherical? Why, amidst the seemingly chaotic dance of celestial bodies, do planets form these elegant, round shapes? It's a question that has captivated astronomers for centuries, and today, we'll explore the answer together. Join me as we journey through the cosmos to uncover the 5 compelling facts that prove, without a shadow of a doubt, why planets are indeed spherical. Imagine a giant cloud of gas and dust, the remnants of a long-dead star scattered across the vast canvas of space. This is how planets begin their lives, as nebulous clouds of cosmic debris. But over eons, an invisible force begins to sculpt these chaotic clouds into something magnificent. That force, my friends, is gravity. Gravity, as we know, is a force of attraction that acts on all matter in the universe. It's a fundamental law of nature, as constant as the rising of the sun. And in the vast expanse of space, gravity acts equally in all directions, pulling inward on every atom and molecule within that primordial cloud. As gravity pulls, it draws the matter closer and closer together, compacting it into a smaller and smaller space. And as this happens, the cloud begins to heat up, glowing with the energy of a billion suns. But gravity's work isn't done yet. It continues to pull relentlessly, shaping and molding the cloud until it reaches the most efficient shape possible. The shape with the smallest surface area for its volume, a sphere. Now, you might be thinking, but Neil, planets aren't perfectly round. What about the bulge at the equator? And you'd be right. Planets aren't perfect spheres. They bulge slightly at their equators. This bulge, my friends, is due to another fascinating cosmic phenomenon: rotation. As planets form and gravity pulls them into a spherical shape, they also begin to spin, to rotate on their axis. This rotation is a natural consequence of the conservation of angular momentum, a fancy way of saying that what's spinning tends to keep spinning. As the planet spins, the material at the equator experiences a centrifugal force, an outward force that pushes it slightly away from the center. This centrifugal force, while much weaker than gravity, is enough to create a slight bulge at the equator, giving planets a slightly oblate shape. But even with this bulge, the overall shape of a planet remains remarkably close to a perfect sphere, a testament to the dominating power of gravity. Chapter 3: Eyes in the Sky, Observations from Space. Our understanding of the universe has been revolutionized by our ability to send spacecraft beyond the confines of Earth. These missions, these daring voyages into the cosmos, have provided us with breathtaking images and invaluable data, confirming what we had long suspected. Planets are indeed spherical. From the iconic pale blue dot image of Earth captured by Voyager 1, to the stunning close-ups of Mars, Jupiter, and Saturn sent back by missions like Cassini and Juno, the evidence is irrefutable. These images, taken from various angles and distances, consistently show planets as round objects, their spherical shapes unmistakable. But it's not just about pretty pictures. Data from these missions, measurements of gravitational fields, atmospheric pressure, and surface features, all align with the model of a spherical planet. Science is about testing our theories, and the evidence gathered from space missions confirms what gravity and physics have been telling us all along. Chapter 4: Shadows of Giants, Eclipses. Eclipses, those celestial ballets where celestial bodies momentarily align, have captivated humanity for millennia. But these events offer more than just a spectacular show. They provide further proof of the spherical nature of planets. During a lunar eclipse, for instance, the Earth passes between the Sun and the Moon, casting its shadow onto the lunar surface. Now, if the Earth were flat, as some still stubbornly claim, its shadow would be elongated, perhaps even rectangular. Yet, time and time again, we observe a circular shadow creeping across the Moon's face. Similarly, during a solar eclipse, when the Moon passes between the Sun and the Earth, the Moon's shadow, projected onto Earth, is also always round. These circular shadows, regardless of the angle or orientation of the celestial bodies involved, are only possible if the objects casting them, our Earth and the Moon, are spherical. Chapter 5: Through the Looking Glass Telescopic Views. Long before we ventured into space, we had telescopes, those ingenious instruments that allowed us to peer deeper into the cosmos. And through these lenses, generations of astronomers have observed the planets, meticulously recording their movements and appearances. Even with the naked eye, we can discern the round shape of planets like Venus and Mars when they are close enough to Earth. But with the aid of telescopes, even the most distant planets in our solar system, like Uranus and Neptune, reveal themselves as round objects. The consistency of these observations, made over centuries and from different points on Earth, further solidifies the fact that planets are spherical. Whether we are observing the planets with sophisticated spacecraft or humble telescopes, the evidence points to the same undeniable conclusion. Outro, keep exploring the cosmos. Thanks for watching. If you enjoyed this video, don't forget to like, share, and subscribe for more fascinating facts about our universe. There's so much more to discover out there, from the birth of stars to the mysteries of black holes. Remember, the universe is a vast and awe-inspiring place, full of wonders waiting to be explored. Keep asking questions, keep seeking answers, and never lose your sense of wonder. Stay curious, and keep exploring the stars.